February 6, 2026, 6 a.m. North Bergen, New Jersey. A construction site just west of the Hudson Palisades sits completely still. No jackhammers, no diesel engines, no workers in hard hats logging hours at the gate. Just cold February air, idle cranes, and 2 tunnel boring machines, each one the length of a football field, each one weighing nearly 1,700 tons, sitting in total silence inside a half-built shaft. A few hundred feet from where their drill heads were supposed to bite into the Hudson riverbed and start carving the next great piece of American infrastructure. Nobody got hurt. Nothing collapsed. Nobody ran out of money. What shut down one of the biggest construction projects in American history that morning wasn't a structural failure or an engineering disaster. It's administrative at the gate. It was an administrative order issued on September 30th, the year before, that froze $205 million in reimbursements Congress had approved and appropriated for the project. Contractors on the ground had been covering those costs out of credit lines for 4 months straight. When that credit ran dry, there was nothing left to do. More than 1,000 union workers showed up to that site on February 6th and were told to go home. The project they were building, the thing those 2 1,700-ton machines were supposed to be drilling toward, is something most Americans have ridden through, or commuted past, or depended on economically, without ever once stopping to think about what's holding it together.
Have you ever wondered what's actually under the Hudson River right now?
There are 2 tubes under there, cast iron and poured concrete. Built between 1904 and 1910 using a method called shield tunneling. A giant steel cylinder pushed forward through Hudson River mud while workers dug the soil out from inside it and bolted heavy cast iron rings to the walls as they went. 2 separate crews started drilling from opposite sides of the river and met somewhere in the middle 90 feet below the surface. The Pennsylvania Railroad opened those tubes for service on November 27, 1910. The year the Titanic was still under construction. The year Halley's Comet last crossed the inner solar system. The year William Howard Taft was sitting in the White House. Those exact same cast iron rings are running 24 trains an hour today, not restored replicas, not rebuilt sections. The original iron, the original concrete. 116 years old and running at maximum operational capacity through every rush hour in both directions, with no backup crossing and no alternate rail route into Penn Station from the west. Every Amtrak train from Washington to Boston passes through those 2 tubes. Every NJ Transit commuter from across New Jersey depends on them for the only rail path into Penn Station. If they go down both at once, or even just one, the entire Northeast corridor loses its central connector. No routing available, no bypass. You either go through those 2 tubes or you don't go at all. They were designed to last 100 years. We are 16 years past that deadline. The part that engineers who've actually been inside those tunnels will tell you keeps them up at night. It has nothing to do with the iron's rings. In October 2012, Hurricane Sandy pushed a wall of seawater through a ventilation ramp on the Manhattan side of the rail yard, near 12th Avenue on the west side. The surge crested above street level and poured down the ramp. The water traveled westward through the tunnel approaches and flooded both tubes simultaneously. The first and only time in the tunnel's then 102-year history that both had been completely inundated at once. All Amtrak and NJ transit service through the Hudson River crossing stopped for 5 days. The Northeast corridor from Washington to Boston was cut in 2. Then the water drained, and everybody moved on.
Here's what nobody stops to think about. The water left that tunnel in 2012. The salt didn't. It's still in there, eating through the concrete from the inside.
That is not a metaphor. Sodium chloride from the Atlantic Ocean chemically bonded with the concrete liner and the bench walls. Those are the 6-foot wide concrete platforms running along both sides of each tube that house the 12,000-volt electrical cables powering every train that passes through. Every time moisture seeps through from the river above, those chlorides reactivate. They attack the steel reinforcement embedded in the concrete. They create microfractures that let in more water, which activates more salt, which opens more fractures. In 2015, 3 years after Sandy, a section of those deteriorating cable systems suffered a major electrical failure inside the tunnel. Penn Station approaches were disrupted for weeks. The FRA's own environmental review was direct about it. The chloride and sulfate left behind by Sandy's water is actively degrading bench walls, embedded steel, and the track bed, and none of it can be properly fixed without taking the tubes completely out of service. Yeah. Amtrak has been running a $150 million interim reliability program, essentially an extremely expensive holding pattern, just to keep those tubes functional long enough for the new tunnel to be finished. That's where the maintenance crews come in, and almost nobody outside the railroad industry knows they exist. Each night, after the last scheduled train clears the tubes, somewhere between 20 and 30 workers from Amtrak's engineering division go underground. The window is tight, typically just a handful of hours before the first inbound morning train has to be cleared, so they move with purpose. Some carry pneumatic jackhammers to knock loose sections of deteriorating concrete off the bench walls before those sections fall onto the tracks on their own. Others carry grout injection rigs to pump pressurized material into surface cracks in the tunnel liner, redirecting infiltrating groundwater away from the electrical systems before it can cause a signal failure or a power trip that cascades into delays for 57 other trains that morning. And then there's the work on the cables themselves. When a section of the 12,000-volt feeder cable system needs repair, workers have to climb down into below-surface splicing chambers. Concrete boxes built into the tunnel floor, too small to stand up in, and work inside them. That's 12,000 volts of live railroad infrastructure in a century-old iron tube, 90 feet below the surface of the Hudson River, during a window that closes the moment the first morning train needs to roll. For bigger jobs, replacing sections of track bed, pouring new concrete, clearing the drainage system underneath the rails, they need the 55-hour weekend windows. Amtrak shuts one tube to passenger service, drops to single-track operation, and sends in heavier crews with concrete forms and digital scanning equipment to map the tunnel walls for new fractures. Every repair is a negotiation between what the infrastructure needs and what the commuter schedule can tolerate losing. It has been working. Barely. But it has been working. The scale of this thing stops making sense when you look at it straight. The Northeast Corridor, the rail line running from Washington, D.C. to Boston through Philadelphia, New York, and New Haven occupies about 2% of the land area of the United States. The region it serves generates 20% of the country's entire GDP. The NEC Commission, the agency overseeing the corridor, has calculated that the line produces roughly $100 million in economic value each day it operates, not annually, per day. If the North Corridor were a country, it would have the 5th largest economy on Earth.
20% of America's GDP. Iron tubes from 1910. The math hasn't changed.
Most of them ride it every morning and never ask what's holding it up.
And the single most congested, most failure-prone, most vulnerable section of that entire 457-mile corridor is the 10-mile stretch between Newark and Penn Station, specifically. 2 tubes, 2.5 miles each, cast iron, salt-damaged, built when Taft was president, running at full capacity every rush hour with zero redundancy. The scenario the Regional Plan Association has been about briefing government officials out for years goes like this. If one of those 2 tubes has to be pulled from service, not a planned rehabilitation, but an emergency failure, the capacity math changes fast and it changes bad. Currently, 24 trains per hour in both directions combined. 1 tube fails, 6 trains per hour. Total, that is a 75% drop in rail capacity across the only Trans-Hudson's rail crossing in existence, effective immediately with no preparation time.
1 tube goes down. NJ Transit can move roughly 20% of its normal load.
The other 80% are on their own. That day, they don't make it in.
Not a worst-case projection. It gets more likely every single year we wait.
The RPA modeled exactly what a 4-year partial tube shutdown looks like for the average NJ Transit commuter. For many riders, daily commute times would increase by more than an hour each way, over 2 hours added to each workday, before accounting for the chaos of hundreds of thousands of other displaced commuters trying to use the same roads and buses and PATH trains at exactly the same time. Bus alternatives can absorb maybe 20% of the displaced rail load at peak capacity. PATH runs a different alignment and runs at full capacity during rush hour. The Lincoln Tunnel and Holland Tunnel move cars. George Washington Bridge moves cars. None of them move the trains. Drive into Manhattan from New Jersey instead, congestion pricing, tunnel tolls, a parking spot that costs more per day than most people's car payments, and a commute that, under normal conditions, already takes longer by car than by rail. The national price tag for a 4-year single-tube shutdown, $16 billion in lost economic output. According to RPA's analysis, more than half of it coming from the accumulated time lost by workers who can no longer reliably get to their jobs. On top of that, the U.S. Police Treasury loses an estimated $1.5 billion in tax revenue it was counting on. State governments across the country, states with no connections whatsoever to the Hudson River, absorb close to $1 billion in their own fiscal losses because the regional economy that feeds national supply chains just got significantly slower. Long-distance Amtrak riders who can no longer get a train to Washington or Boston shift to air travel, driving DC to New York airfares up significantly, and squeezing out the leisure travelers and small businesses that depended on affordable rail as an alternative. And somewhere in Edison or on a loading dock in Elizabeth, truck driver sits in traffic that didn't used to be this bad, adding costs that eventually appear in the price of whatever he's delivering to someone who has no idea the tunnel had anything to do with it. All of that. From 2 tubes of corroded iron under a river, built to last until 2010. You understand the point. This is why the Gateway program exists. And it is, without any overstatement, the reason engineers at the FRA, the ASCE, and the NEC Commission have called it the most urgent infrastructure project currently under construction in the United States. Here's what it's actually building. The core is the Hudson Tunnel Project. 2 brand new tubes running parallel to the existing North River Tunnel, extending 2.4 miles from a portal in Secaucus, New Jersey under the Palisades Cliffs, across the riverbed and connecting to Penn Station from the south. New alignment, modern construction, designed for the next century. Once those new tubes are open and operational, Amtrak can finally take the old tubes offline, one at a time, for about 18 months each, and do what should have been done a decade ago. Strip out the century-old track, rip out the salt-contaminated concrete, replace every electrical system, and rebuild the bench walls from scratch with modern materials. When all 4 tubes are back in service, the Northeast Corridor will have twice the Trans-Hudson Rail capacity it has today. 4 tracks where there are currently 2. 2 tunnel boring machines assigned to drill. Those new tubes were fully assembled and ready to begin their underground run by early 2026. Pre-construction at multiple sites. In Hudson Yards on the New York side, in North Bergen, and through the Palisades on the New Jersey side, had been underway for months. The riverbed stabilization contract, the first direct construction work on the tunnel itself, had been awarded in the months prior. Everything was in place. On September 30th, 2025, the administrative order froze the reimbursements. By January 2026, the Gateway Development Commission's credit lines were exhausted. On February 5th, construction was formally suspended. The notices went out that evening. Those were the workers you saw at the top of the story, showing up the following morning to a site that had been formally shuttered the night before. The boring machines sat in their shafts. The GDC filed for legal relief in early February 2026. New York and New Jersey filed separately. A U.S. District Court issued an emergency order requiring reimbursements to resume. Washington released funds in 3 tranches, $30 million, then $77 million. Then the remaining $98 million, plus an additional $30 million for January work already completed, with the full $205 million cleared by February 18th. The matter remained in that same court through March 2026. Construction restarted. The tunnel boring machines are still in their shafts, waiting to move. The 2035 target for the new tunnel remains on the schedule.
2 new tubes. The old ones fully rebuilt. 4 crossings where there were only 2.
What actually changes when all of this is done? That's the part worth holding on to. A NJ Transit commuter from Metro Park or Princeton Junction won't just get a more reliable trip to Penn Station. The whole corridor gets redundancy it has never had in the Amtrak era. Trains can be rerouted around a failure instead of grinding to a halt. Maintenance windows open up without collapsing service. Yacela can run on a schedule it can actually keep. More frequent trains make rail a viable choice for workers who currently drive because the existing timetable doesn't fit their hours. This is not a capacity expansion project. The Gateway program's own documentation says that clearly. It is a reliability project. It is at its core a rescue operation for 116-year-old infrastructure that was designed for a country that no longer exists, carrying the economic weight of 20% of modern America's GDP. Kept alive night after night by 20 to 30 workers with jackhammers and grout guns, working a few hours before dawn, 90 feet below a river that is still slowly dissolving the walls around them. 2 1,700-ton machines are sitting in a shaft in New Jersey right now, waiting, and while America races to save the tunnel it already has, somewhere in Texas, dropping what some projections put at close to $500 billion into the ground.
To build something the world has never seen before. If you thought freezing a riverbed was an extreme problem to solve the ride, hit subscribe and turn on notifications. What's coming next makes.
This look simple.